Okay, so in grade 10 you did factoring. Do you remember that word, factoring? And we have 4 factoring styles. So simple trinomial, complex trinomial, GCF, and difference of squares. Those are your 4 types. We're going to do these 3 today. We're not going to do complex till tomorrow because that's a whole day of teaching. Okay, so simple trinomials. The rule. It will always have to multiply to the end and add to the middle, right? Remembering those rules? What multiplies to the end and adds to the middle. Okay, so I'm going to also tell you this. I'm going to just, go back to the top here. Factoring happens when you have 2 variable types. If you have 2 variable types, you can't isolate anymore. Would that make sense? You can't isolate if there's 2 things going on. So when I look at this, there's an x squared and an x, which are actually 2 different variable types. So I want you to think like this. Do you understand when you measure something, you can have feet and you can have square feet? You can't put those together, can you? Do linear feet and square footage, can you put them together? No, they're separate things. So you can't treat these the same, they're separate things. So I can't isolate something, so I'm going to factor. So give me 2 brackets. And factoring is breaking down the FOIL in an opposite way. So first times first has to make x squared. So x times x. The last times the last has to make this last. And then that O and that I have to combine to make that. So what multiplies to 15? And you got to make a 2 with it when you add them together. So I'm going to pick 5 times 3. One of them is negative because it says negative 15. And then I better make sure that it makes a plus 2 in the middle. Okay, then what are your solutions? So what are your x-intercepts? So you're thinking, what number causes a 0 in that factor? Negative 5. And what number causes that bracket to be 0? Positive 3. So what is this all about again? This is, again, what it's doing. It's telling me my intercepts of my parabola. That's what it's doing. Where does the height equal 0? That's what it's doing. Where is the height 0? Okay, can you do the second one on your own? So basically, I need you to think about 2 numbers that multiply to 30. And then you can add those numbers together to get 11 out of it. So I picked a 5 times a 6 to get 30. And then what are you going to do with the signs? Because it has to multiply to positive, but then add to negative. So would it make sense that they're both negative? Okay, and then your x-intercepts are at 5 and at 6. Okay, one more of those. Okay, so this one, I'm not even going to start factoring it. I don't like this. So when I factor, I never, ever, ever start with negative liters. It just doesn't make it very good to start factoring. So how could I change this equation so that I don't have to work with this negative start? Any suggestions for me? I don't like it. Is there some kind of math maneuver we can do that it would get that out of there? We could just say we would move it to the other side. Yep. Or you could just make the statement that you're just going to times everything by -1. Those ideas are both the same. So can you maneuver the equation differently then? Whatever thing you're thinking about. You could move to the other side, or you can just state I'm timesing everything by -1. Okay, now I can factor this. This looks a lot easier. So did you see how I changed the signs to everything then? So x times x, can you think of multiples of 22? And then those numbers would get you 13 on the add. 11 times 2 is 22. So again, what is this all about? Well, these are the x-intercepts of your parabola. But what's the one thing that's different about this parabola versus our last drawings? It's what? It's negative, so my parabola would be flipped. Okay, that's the only thing. It doesn't change your x-intercepts, but that negative is just applied in the drawing, right? The flip. Okay, so that's simple trinomials. Multiplies to the end, adds to the middle. All that's flowing back, right, from grade 10. Okay, so the next style is GCF. And the GCF is when there's something common. And GCF, I actually always glance for it first. I always look for it first. So there's two terms here. What's in the side, both of the terms? What could I divide each by? Looks like an X. So this is what I do. I go X bracket. X times what? X times what? So I have two terms. So X times what makes the first? X times what makes the second? Okay, and your brain goes better forward, so can you distribute and end up with that? If I do this, do I get that? Okay, so on this one, there's an x here, so what would x have to equal? In order for that factor to be 0, x would have to be equal to, did you pick 0? If x was 0, that number would be 0. And if x was 12. Okay, number 2. So this is a GCF. Again, I gave you a GCF example. What could you take out of all three terms? There's three terms here. It looks again like there's an x I can take out. Okay, so there's three terms, so you need three pivot arrows. X times x squared makes x cubed. X times 3x makes 3x squared. X times -18 makes -18x. Okay. I'm actually not going to solve right now. There's more work to be done. What is the more work to be done? Anybody see where we could go? I think I need to take that more. What would I do with that strategy? Simple trinomial, do you recognize it? So this is a simple trinomial. So what multiplies to 18? Looks like 6 times 3, because I need to make a 3 with it. This person has something wrong, and this is a very common mistake. What did this person do wrong? So they went from here to here. They're missing something. Can you identify my error? You're missing the x. You still have to bring it. You can't just leave it. It's like forgetting one of your children at the mall or something. You don't want to do that. Okay, there's actually 3 answers here. There's 3 answers for x. So 0, -6, and +3. So you don't know this. My grade 12s will learn this, but you get to do it in grade 12. This is actually not even a parabola anymore because it's cubed. You don't have to know this, but this is what it's going to do. It's going to cross 3 times and make a different shape. So you get to learn that in grade 12. Okay, the last one. It is a GCF. You could actually, what other strategy could you do here? I would have picked something else. We are going to GCF it, but there's actually a better strategy to identify. You could isolate, right? Because there's only one variable type in this thing. Okay, but we're going to GCF. Would you agree that an 8 could come out of those terms? 8 times what? 8 times what? To make the 2 terms? And do you recognize this as anything? Anything you recognize with this section? It's a different name now. It's a difference of squares. You recognize that one? So then how do you do a difference of squares? So what times what makes x squared? What times what makes 4 and technically adds to 0 in the middle? That's what really is there. There's a 0 in the middle. So that's why you need a +2 -2. So multiply to the -4 and add to 0. So do you know the person who would have isolated? So let's just solve this by isolation here as well. So if I would have isolated, I would have added 32. And then I would have divided by 8. Do you see why it's important to answer what we've been answering? We've been doing plus or minus answers. And look at this. Does that correlate with that? Yeah. So that's why it's so important not to forget when we are isolating, when you have a squared, you could do a plus or a minus. Okay, last example of the day. So this is another difference of squares. So can you give me 2 brackets? What times what would give you to an a4? So you're going to need an a squared and an a squared. What times what gets you 256? Anybody know that number? Anybody test it? Is it 16 times 16? Yeah? Okay. Okay, so plus, minus. Now what? What is a type that you would recognize right now? I see a difference of squares here. This is not a type. This is not a difference of squares. Do you understand that? It's not a subtraction, so it's not a difference of squares. This is actually not factorable. That one you can't even go further. Why can't you? Here's a reason. If your parabola is up 16, there's going to be no x-intercepts. It's not factorable. Another reason, if I try to isolate a squared, I would have to minus 16 and then square root negative 16. Not possible. So it's not factorable. So I'm going to leave it as it is. I'm going to rewrite it, but there's nothing I can do. And then this I can work with. So then that can break down with the plus minus 4. So this one breaks down, difference of squares. This one, please recognize it's not factorable. Okay, I'm going to highlight that because I get this on the test where people get stuck there. It's not factorable, that one, so it just gets rewritten. So no, hey, that's a this type, that's a this type. Look at that, it's not one of our types. So A equals negative 4 or positive 4. So also, I'm just going to go back here. Do you recognize I could have isolated as well on this question? Would that work here? Because I only can see one variable type. So I would add and would you know that I would have to fourth root that number to solve there? Do you know how to do that work in your calculator? How do you fourth root? Does anybody know their buttons? Okay, so here's the button that my calculator would do this work with. It's called the x root of. Okay, that's my button. I would have to push 4 and then that button. I'd have to push the 4 before it. The fourth and then the any root button of that. And then that's how I would get the number 4.